Now let us see the uses of washing soda. Washing soda is used for washing clothes. It is also used for softening hard water. That means for removing the permanent hardness of the water. Now here you people will feel that how water is hard. Water is liquid and hard is the property of solid. Then how water is termed as hard water? The water which consists lot amount of the salts, that is sodium chloride, magnesium chloride, barium chloride and many more types of salts when present in the water, then such water are termed as hard water. How you will identify it? See, sometimes when you take a bath and you apply a shampoo in your hair, or when you apply soap on your body, and when you pour a water on it, you can't find a foam or a lather, right? Or you find very less amount of foam or lather, that means the water is hard. So this hardness of the water is removed by boiling the water or by adding such type of chemical reagents, and so it becomes soft, and then such water will give a good amount of foam and lather, right? Foam or lather, it means feen away, right? So it is used for softening the hard water. Sodium carbonate is used for manufacturing detergents and soap. It is used in manufacture of sodium compounds such as borax, Na2B4O7. Borax you would have heard, which is used as a powder in the skin fungus medicines, as well as it is used for preparing the unbreakable glasses also, right? Borosil glasses along with the silicone. You will learn in higher classes. Sodium carbonate is also used in making glass, paper and paint industries. It is used as cleansing agent for the domestic purposes, right? So now let us see the further. One more topic is water of crystallization. You have seen the formula of washing soda. It is Na2CO3 10H2O. Then what is this 10H2O? It is the water of crystallization. Crystals of some salts contain certain amount of associated water. Associated, that means the water which is joined with it or which is along with that compound is termed as water of crystallization. The fixed number of water molecules associated with the crystal or molecule of any salt. The fixed number of water molecule associated with the molecule of any salt is called water of crystallization. The salts containing water of crystallization are called hydrated salts, and salts which are not containing water, they are termed as anhydrous salts. Some typical salts which contain water of crystallization are copper sulfate, which is also written as copper 2 sulfate, which shows that copper is here in positive 2 charge. Its formula is CuSO4 5H2O. It is blue in color. The next is iron sulfate, that is iron 2 sulfate. Here also iron 2, it means iron is having plus 2 charge. FeSO4 7H2O, light green. When I say plus 2 and plus 2 charge, here we have learned in 9th standard formation of the chemical formula, where positive charge goes to the non-metal and negative charge goes to the metal, and thus this formula takes place, right? Borax, just now I told Na2B4O7, it is sodium borate having the formula Na2B4O7 along with 10 water molecule. It is white in color. Epsom salt is magnesium sulfate, which is MgSO4 with 7 water molecule. It is also white in color. Washing soda is sodium carbonate Na2CO3 along with 10 water molecule. It is also white in color. Gypsum, again it is calcium sulfate CaSO4 two water molecule, it is also white in color. The water of crystallization can be removed by heating. Now let us see the activity or an experiment to prove crystallized water can be removed by heating or salts can be dehydrated by heating. The aim is to show that water of crystallization can be removed by heating. The materials we need is powdered CuSO4 crystals 5 gram, that is blue in color. But apparatus we need is hard glass test tube holder, gas burner, dropper and some amount of material, I forgot, some amount of water. What is to be done is, we need to take a copper sulfate powder CuSO4 blue in color in a hard test tube and we need to heat it at very low flame. And we need to hold this test tube with the test tube holder, not by the hand. Now what happens when you heat this copper sulfate at a low flame? We will observe that slowly the water droplet starts coming and it will be accumulated on the inner surface of the test tube. You can see here. And gradually the copper sulfate will become white. Now we are in need to cool this and then add some water drops into the test tube on that white copper sulfate powder. Right? This white copper sulfate powder is here. We are in need to add water drops on it. What happens here? After some time you see gradually this copper sulfate which was white will now turn blue because it has absorbed water and this is a water of crystallization. So here, because of the presence of some amount of water on heating, the water compound is escaped from it, that is removed from it and it becomes white. When again we are adding, it becomes blue. So from this we can conclude that water of crystallization can be removed by heating. Now let us see the next topic. It is deliquescent salts. A new word for us, deliquescent salts. What is deliquescent salts? Please pay attention here. Certain anhydrous or partially hydrated. I just told in the previous video anhydrous, that means the water component is not in the compound. Or if it is partially hydrated, that means some amount of water is present. Then such salts can absorb moisture from the air and become moist. This property is called deliquescence. What is it called? Deliquescence. Now the salts showing deliquescence are called deliquescent salts. As for example, salts of anhydrous magnesium chloride and calcium chloride are highly deliquescent, and due to this somewhat amount of magnesium chloride is present in common salt, and because common salt NaCl is obtained from the seawater and magnesium chloride is also present in the seawater, so some amount of magnesium chloride is present in NaCl. So common salt absorbs moisture due to presence of this very small quantity of magnesium chloride in it, and it becomes moist during rainy season. If you have observed in your home during rainy season, the sodium chloride, common sodium chloride, that is common salt, that is we can say table salt, mittu, it becomes a lump of salt, gattha bani jai. That is the because of this deliquescence property and deliquescent nature of the magnesium chloride. And the next topic is a more compound, that is plaster of Paris, which is POP. You might have heard that for the relief of the heat in the summer, people have started getting their ceilings by POP, plaster of Paris. Its chemical name is calcium sulfate hemihydrate. So from the name only we can give the molecular formula calcium Ca, sulfate SA4, hemihydrate, that means half molecule of water, 1/2 H2O. How it is prepared? It is obtained by heating gypsum. What is gypsum? Calcium sulfate with 2 water molecules, CaSO4 twice H2O. When this gypsum is heated at 373 Kelvin, by losing its that means gypsum's water molecules, POP is obtained. Calcium sulfate with 2 water molecule gypsum is heated at 373 Kelvin. Calcium sulfate with hemihydrate molecule, that is half molecule of water, that is plaster of Paris, is obtained, and one and half molecule is separated. During the preparation of plaster of Paris, temperature should be controlled carefully. This is the very important factor for the preparation of plaster of Paris, because what happens, anhydrous calcium sulfate will be formed. If temperature is not maintained properly, then calcium sulfate will be removing its water and it becomes anhydrous and it will form. So what happens, which does not set into hard mass when mixed with water, and then such calcium sulfate when mixed with the water, it will not set in a hard mass, and thus POP which is obtained will be of poor setting property. What are the properties of POP? It is white odorless powder. Odorless, that means it is not having peculiar smell, or we can say without smell. It reacts with water and forms a plastic-like mass, that is hard solid mass, gypsum, within 10 minutes, very quickly, and evolves heat, which is called the setting process. Calcium sulfate, that is POP with hemihydrate molecule, when reacts with the water, it will give back the gypsum in very short span of time. What is the uses of POP? POP is used in sealing air gaps. Where the air gaps is there, the sealing of it is done by POP. It is used in making cast for the statues, toys, decorative objects and idols, that is murti. It is used in plastering the fractured bones to keep the joints in a fixed position. It is used in making blackboard chalk. It is used for making the surface smooth, and one more I told in the beginning, for the sealing of the room to get relief from the hot or scorching heat. Now at the last I would like to say that how the name plaster of Paris has come. All other names we have seen, it is sodium carbonate, sodium hydrogen carbonate, sodium chloride, right? Then why this is not called calcium sulfate hemihydrate and it is called plaster of Paris? So here it is, gypsum was mainly found in Montmartre town in the Paris, and when this gypsum was heated, on heating it, a powder was obtained, white color powder was obtained, and so this powder is obtained from heating gypsum in Montmartre in Paris, so it is termed as plaster of Paris. With this we have finished our second chapter. So go through all the videos properly, and now we will start with the new chapter, Before that, I will give you the solved exercise.